Guys, welcome back to my channel. So today let me talk about this one concept in microtheory. So I found that a lot of my students got confused with. So that's the relationship between production function and its graphical display. And how do you draw the graph based on a particular functional form? Or if you're given particular functional form, specific production curve, how do you know what the mathematical expression look like? Okay, so yeah, I'm going to give you this one example. I am hoping that once you figure out whether you know how to do this question, how to solve this problem, you understand the relationship between the functional form and the graphical display of the functional form. Okay, now let's get started. Look at that question. We have a production function that's cubic production function with a fixed capital. So we have quantity Q output produced equals a function of L. So that's labor input. We're holding all other variables constant. We're holding all other inputs constant because this is a short run production decision, or cubic production function with a fixed capital if we only consider two inputs, or we can write this way: f of k bar, right? Fixed capital. But here basically just the quantity demand, the output is determined by only how much labor you employ. So you're given this functional form: Q equals A plus B L plus C times labor input squared plus D L cube. And now you're also given this graph. So that's the quantity, output produced, and labor. So the graphical display look like this. Right? This is a very general or generic production curve, right? When we only have one variable, input variable, labor. So now quantity equals F of L. So this is all the information you are given. You're given this functional form. You're given this, what the curve look like graphically, and you're also you need to figure out the sign. The sign of A, C, and D, especially C. So look at the sign of A. The A is very easy because when A equals Q equals A when L equals 0, right? So when L equals 0, you can easily figure out quantity output produced is 0. So A is 0. So now we know A is 0. And then we can rewrite this production function with this new information. Quantity equals BL plus CL squared plus DL cube. And now how do you determine the sign of C and D? It's actually turned out that B is not that important, or with the current information we can't tell the sign of B. Okay, so look at this curve, right? So usually we look at, this is the production function. You want to determine the sign, right, of this constant where A, B, C, D are constant. And so the first thing to look at is the slope, how slope changes as the variable x or labor increases. So the slope is positive anywhere, positive. So the slope is changing quantity over changing labor. That's additional output produced when you have one more unit of labor. So actually this marginal product of labor. So equals, if you consider, look at the slope of any point, the slope actually, any point of the curve equal the slope of the line that is tangent to this point, or tangent line. So that's dq over dl. So that's the first order condition, or differentiate this production function with respect to L. So derivative, right, dq over dl equals, you have the functional form here. So that's very basic calculus, equals B plus 2C times L plus 3D L squared. Okay, so now how do we know that? We know this is a positive. Okay, this is a positive. What does that tell us? We need to figure out the sign of D and C. So now let's look at the change in slope. So the slope is, right, slope becomes greater and greater, right? Larger and larger, right? The slope, the tangent line is steeper and steeper up until this point, maybe. And after L1, and the slope become flatter and flatter. So that means you look at the change in slope. Let's look at the change in slope, which is MPL. So it's become larger and larger. So probably we know that, right? So the diminishing marginal product does not exist immediately after first worker hired. So when the first few worker hired and they can divide tasks, do teamwork, they can work more productively. So each additional worker add more and more and more. So marginal product labor is actually increasing. So hire one more worker, right? One additional worker can produce more, right? Can add more to the production. So, but after a certain point, so the more worker you hire, because you're holding capital constant, the more worker you hire, and then the less productive each worker is, or each additional worker add less to total production. Okay, so now this is the change in slope, change in marginal productivity is first increase and then decrease. So that means there is a maximum there. Right, so there's a maximum. So you know this curve is a quadratic function. So it should look like this. This is, if you look at the marginal product labor, and this is the labor. Marginal product labor increasing and then decreasing. First increasing and then decreasing. So that means there's a maximum. If there's a maximum, you should know that you have very strong math background. If you should know that this which color is good. So you should know that this D must be less than 0. To make sure that this function has a maximum. So now you know D is less than 0, right? And A equals 0. So what about C? There are two ways. So there's one way to do it, which is a little bit more, more straightforward, easier to understand. Is so look at this point. This point is maximum. That's so at this point, right? So at L1, the marginal product labor reaches the maximum and then start to decrease, right? So now you can just find this marginal product labor. So when this is marginal product labor, and then you find the maximum. The maximum is, let me use this color. So maximum is change in marginal product labor over change in L equals 0. So that's maximum marginal product labor. So that equals, so this thing is first order condition, right? Differentiate this whole thing, this marginal product labor, and with respect to L. So now you have that equals 2C plus 6DL. So equals 0. So you can get a value for L. Okay? So the L equals negative 2C over 6D. So you know D is negative. You figured out. You already figured out D is negative. So L can be negative. L can be negative. So C must be positive to ensure that this whole thing is positive. So that's the one way. It's a kind of easier way to determine C is positive. And a more intuitive way to determine whether the sign of C is to look at the change in slopes. So this is the slope, right? This is the slope, marginal product labor. This is the functional form for slope, marginal product labor. Okay, let me write that down here. Marginal product labor equals B plus 2CL plus 3DL squared. So now this is the slope. And let's look at the change in slope. The change in slope, we know that is increases and it decreases. So the change in slope, when there's a change in L, so that's the slope of a marginal product labor, or would it be the change in marginal product labor when there's a unit change in labor? So that equals first order condition, C2C plus 6DL, right? So now this gives you the relationship between marginal product labor and the amount of labor input. So if this is greater than 0, that means more labor, more marginal product labor, right? If this is less than 0, that means you hire more and you get it negative, or you get less marginal product labor. So let me write this way. So let me write this way. So this gives us the relationship between marginal product labor and so between the change in marginal product labor and the change in L. So if L and the marginal product labor move in the same direction, is positive, right? Is moving in the same direction, there's positive correlation. If more labor hired, less change, right? Less than 0. So now let's come back to this, right? To this graph. So look at the change in slope. So before L1, right? Before L1, I can't find a good, right? Before L1. So before L1, the slope becomes smaller, become larger and larger as L increases. So before L1, this is greater than 0. So that's this 2C plus 6DL greater than 0 because they move in the same direction if L less than L1. But after a certain point, after L1, 2C plus 6DL less than 0. So that's, you see, the slope is smaller, right? Slope becomes smaller as L increases. So if L greater than L1. So now you look at that. This is a change, right? This is a change. So I know this is an intuitive way. I try to explain that in class, but the turn out this way is a lot easier to understand, right? So now let's continue this way. So we have this. So this actually is the change in marginal product labor again, right? And a change in L equals 2C plus 6DL. And we know D is negative, so we already figured out D is negative. So now this should be changing MPL over changing L. This is L. Negative, that means is, so is a downward sloping, right? Downward sloping. So we need to figure out the sign of C. So we know that before L1, this whole thing is positive, should be above 0. After L1, this whole thing is a negative, right? So now this indicates the intercept here, the y-intercept 2C is positive. So that's another way you figure out C is positive. Right, this is there are two different ways, but I know this is a lot of this very challenging. This is a challenging question, but the thing is, you should know that the main takeaway is you should know that the slope or first order condition is very useful when we analyze the change in y when there's a change in x, right? So the change in y over change in x. So changing quantity. Right, changing quantity when there's a change in labor, so the marginal product labor, and a change in marginal product labor when there's a change in L. This measures how marginal product labor change when there is a change in labor input. So this is first order condition, the second order condition of the production function. So yeah, is that challenging for you? So yeah, that's it. Yeah, thank you so much for watching, and I'll see you in the next one. Bye.